Welcome back to Just Academy Mathematics YouTube channel, where we make you a mathematics genius. Today we'll continue in our series on matrices and determinants. And we are concentrating on equal matrix today. Equal matrix. What is when is two or more matrices said to be equal? Two or more matrices, as you can see in this right up here, two or more matrices are equal if they have the same dimension, same values, that is entries or elements, and on the same spot or position. Two or more matrices are said to be equal if they have the same dimension. Of course, you know what dimension of matrix is. For instance, let's take this matrix for example. This matrix has two rows, one row, another row. The first and the second row, that is two rows. How many columns? 1, 2, 3 columns. So the dimension of this matrix is the number of rows and the number of columns. That is 2 by 3 matrix. This is a 2 by 3 matrix. This is a 2 by 3 matrix. This is 2 rows, 3 columns, 2 by 3 matrix. But this is 3 rows, 2 columns. So this is 3 by 2 matrix. 3 by 2 matrix. This is 2 by 2 matrix. This is 3 by 3 matrix. So the number of the row and the number of the columns give you the dimension of the matrix. So for two matrices to be equal, the dimension must be the same. That is the first thing. Then the second, the matrix will have the same entries. What do I mean? If 3 is starting here, 3 will also start here. No, let's take this example. Let's look at these examples. Look at 3 here, 3 here. The same value, the same position. -2 here, -2 here. 0 here, 0 here. On the same position, the same value. 4, 4, 7, 7, 11, 11. Therefore, this matrix, these two matrices are equal. This symbol here means not equal. Now, let's see why they are not equal. These two matrices are not equal simply because the dimension of this matrix is 2 by 3, while the dimension of this matrix is 3 by 2. So because they don't have the same dimension, there is no need considering the entries. So they are not equal. They can never be equal. Now, these two matrices are not equal, regardless of the fact that they have the same dimension. This is a 2 by 3 matrix, and this is also a 2 by 3 matrix. But the entries are not the same. The elements are not occupying the same position. Look at 3 here. Look at 4 here. This is 2 here. This is 7 here. So the elements are not the same. The entries are not the same. Therefore, the matrix cannot be equal. The same thing is applicable here. Notice that when here is 1, here is -1. So these two matrices cannot be equal. Now, come and see another equal matrix. This matrix is equal to this matrix. Why? Because the dimension 3 by 3, 3 by 3, the same dimension, the same entries, and at the same spot. -2 here, 2 here, 2 here, 0, 0, 1, 1, -1, -1. The same entries are the same spot, the same dimension. Therefore, this matrix is equal to this matrix. Now, let's take example. I'm going to be showing you 2 examples. Now, look at this. The first example we're going to be looking at. The first example says, given that this matrix here is equal to this matrix, find the value of P, Q, R, and S. If you have followed what I explained, then getting the answer will not be a problem. Because if these two matrices are equal, the value here must be equal to the value here. Therefore, if here is 3 and here is X, therefore we can conclude that S is equal to 3. And if here is minus 5 and here is y, therefore we can also conclude that y is equals to minus 5. What is remaining now? Of course, if here is 0 and here is p, we can also conclude that p is equals to 0. We can solve for the next one. If here is 2 minus 2q and here is 7, therefore we can also conclude that minus 2q is equals to 7. Hence, if we divide both sides by minus 2 in order to find q, we will get that what? Q is equals to, it's either you leave it as 7 over minus 2 or you can present it as minus 3 whole number 1 over 2. So these are the value of S, Y, P, and Q. And it's as simple as this because the matrices are just equal. Now let me show you one more example. So look at this last example now. If you look at this, they say that find the possible value of X and P if this matrix is equals to this matrix. Of course, if they are equal, they must be the same dimension, the same entries. Of course, this is 2 by 3 matrix, the same dimension. So the entries must also be the same since this is equal to this. So this first entry here must be equal to this first entry here. So to find the value of S, all we need to do is that X plus 1 must be equals to 3S minus 5. This first entry equals to this first entry. So let's find S by collecting like terms. We have X minus 3X is equals to what? Minus 5 minus 1. So if we advance on that, we are going to get minus 2x. This is 1s minus 3s minus 2s is equals to minus 5 minus 1 is minus 6. So we divide both sides with the value, the coefficient of x, which is minus 2. So I have minus 2x over minus 2 is equals to minus 6 over minus 2. This will go with this. S is equals to what? 3. Positive 3 because this is minus divided by minus is plus. So 6 divided by 2 is 3. That is for the value of x. Now, following the same pattern, we can find the value of what? P. Notice that the last entry here must also be equals to the last entry here. So I can say that P squared minus 6 is also equals to 5P minus 12. This equals to this or this equals to this is the same thing. Now, obviously, this is a quadratic equation. So what am I expected to do? What we are expected to do now is to balance the equation so that we can factorize it. So we bring everything to this side. We have that what? P squared minus 5P minus 6 plus 12 is equals to 0. Are you with me now? So we can combine these two. So we have that what? P squared minus 5P plus 6, because minus 6 plus 12 will give us plus 6 equals to 0. So what do we do next? We factorize. Factorization of quadratic is the shortest and the simplest method of solving quadratic equation. There are other methods like completing the square method, formula method, and all that. But let's factorize this. To factorize this, we look for two factors or two numbers that when we add them together, it will give us minus 5. And we multiply both numbers, both factors together, it will give us plus 6. The two factors are minus 3 and minus 2. Minus 3 minus 2 is equals to minus 5. Minus 3 times minus 2 is equals to plus 6. If you don't know how to get the two factor, you can go and watch our video on a quadratic equation, quadratic series. Now let's proceed. So P squared minus 3P minus 2P plus 6 is equals to 0. Nothing has changed. This P squared, look at it. This minus 5P is this 2. Minus 3P minus 2P is minus 5P. This 6, look at it. We factorize in pairs. The first two, the first pair, what is common? P is outside. What will remain? P minus 3 inside. In the second pair, what is common? Minus 2 is outside. What will remain? P minus 3, of course, equals to 0. If you open the bracket, you get back to this. Minus this times this will give you minus P, 2P. Minus 2 times minus 3 will give you plus 6. And the rule is that the two brackets must be the same for you to know that your factorization is correct. So if we pick the common bracket out, what will remain? It will remain what here? P. It will remain what here? Minus 2 equals to 0. So what do? We equate this to 0 to get our final answer. What does that mean? P minus 3 is equals to 0 and P minus 2 is equals to 0. So finally, to conclude this, we say therefore that P is equals to 3 and P is also equals to what? 2. So these are the two values of P that will satisfy this matrix, that will satisfy this equation. How? If you put 3 here now, for instance, 3 times 5, 5 times 3 is 15. 15 minus 12 is 3. If you put 3 here now, you have 3 squared is 9. 9 minus 6 is 3. Can you see? So here is 3, here is 3. And if you also put 2 here, the value you get here is the value you get here. If you put 2 here, you get 10. 10 minus 12 is minus 2. If you put 2 here, you get 4. 4 minus 6 is minus 2. So either 3 or 2 will work for P for this equation to be equal. So this is how to solve equal matrix. No matter how complex it is, the entries, the dimension must be equal. So make sure you watch our next video as we move into addition and subtraction of matrix. Now remember, Just Academy has more than enough professional, well-trained tutors that is ready to take you on a one-on-one private tutorial. So if you want a one-on-one tutorial, don't hesitate to chat us up on the WhatsApp link you are seeing, and we'll take it up from there. Thank you. See you in our next class.